Bismillahirrahmanirrahim. In this session, we will discuss exercise 6.12, and that is exam exercise from additional mathematics course for IGCSE and O level students. This is all related to the exponential and logarithmic functions, and here we will discuss some of the problems. So let's start. Question number 1. Using the substitution y is equal to 5 power x, show that the equation this 5 2x plus 1 minus 5x plus 1 plus 2 is equal to 2 5 power x can be written in the form of ay square plus by plus 2, where a and b are constant to be found, and hence solve the equation this. So we will solve this first problem. So let's this first one, y is equal to 5 power x, and show that this equation in the form of this. So let's this is 5 power 2x and 5 power 1, and that is 5, and this is 5 power x, and then 5 power 1 is separated, and this is 2, and this is 2x 5 power x. Let this 5 power x is equal to y. So in place of this we will write y. So this is y, so this is 5 2x, so this is y square. So 5y square minus 5y plus 2 is equal to 2y, because this is 2y. So we will shift this 2y to on this side. So this is 5 square minus 7y plus 2. So this is plus 2, and this b is basically minus 7 and a is 5. Now solve b part. We have given this problem and we have to find the solution. From part A, we can see that this is equivalent to 5y square minus 7y plus 2. So this is equals to 0. So we take this middle term, divide minus 5y minus 2y. So this is 7y. So because this 5, so we have to factorize it. By factorization, we have obtained y minus 1, 5y minus 2 is equal to 0. If y minus 1 is equal to 0, then y is equal to 1. If 5y minus 2 is equal to 0, then y is equal to 2 upon 5. Since we have assumed that y is equal to 5 power x in part A, so in place of this y we will write 5 power x is equal to 1. So similarly here, this is 1, so 5 power 0 is 1. So this x is equal to, so the base is same, the power is same, so x is equal to 0 is one of the solution. And on the other side we have 5 power x is equal to 2 upon 5, and taking log on both sides. So this is x ln 5 is equal to ln 2 upon 5. So this x is equal to ln 2 upon 5 divided by ln 5. So on resolving we obtain this solution. So this is the answer. So we have two solutions. One is x equal to 0 and the other one is x equal to minus 0.569 or 0.57. Let's solve question number 5. So we have given that log 4x is equal to 1 over 2. Find the value of x. Find the value of x. And in the second part, solve 2 log 4y minus log 4 5y minus 12 is equal to 1 over half. So we will solve this exercise 5, question number 5. So this is question number 5. Log 4x is equal to half. So we have to find the value of x. So log 4, so we take the 4 here and 4 here. So if we take 4 power log 4, so this becomes x is equal to 4 power half, because and 4 power log 4 is same, so it will be 1. So x is equal to 4 power half, so x is equal to 2. In the second part we have to solve this log 2 log 4y minus log 4 5 minus y 12 is equal to half. So this 2 will be here, so log 4 y square is equal to log 4 5 y minus 12 is equal to half. Since this is subtraction, so we can place this in the division. So log 4 5 square divided by 5 by minus 12 is equal to 12. 1 over 2. So by taking 4 here in the denominator as a base and 4 power half, so we can say it will be reciprocal, so it will be odd. So if we take power 4 power this log, then 4 power half, same on both sides, so this becomes 1 and this becomes 4 power half. So this is y square 5y minus 12 and this is 2. So this y square 5y minus 12 is equal to 2, and by shifting it here, so this y square is equal to 2 into 5y minus 12, and now after some manipulation 10y, this is 24y, and by shifting it on the one side, so y square minus 10y plus 24 is equal to 0. Now factorize it, and y minus 6 and y minus 4. So this is y is equal to 4 and y is equal to 6 is two solutions. So we have to since this is y, so we have to obtain only y, so we have not supposed anything, so this is solution. And now let's solve question number 7. We have log a means log, when we write like lg, then it is assumed as log 10. So log 10 a plus log 10 3 log 10 b minus 3 as a single logarithmic function. So this b 3 will be power of b square b, so this will become b cube, and log a, since this is addition, so a and b will multiply, and this is without log, so we can write it log 10 power 3. So this 3 will be here and log 10 will be cancelled out, so this will be 1 reciprocal. So this 3 here, so in place of 3 the log 10 can be multiplied to make it logarithmic function. So this is a b cube and this is 10 cube in the denominator, so a b cube and 10 power 3 in the denominator, so a b cube, and this is 1000, so 1000 is lg. So this is single logarithmic function. Let's solve this question number 9, and the temperature of an object T minutes after it removed from a heat source is given by this. Suppose some of the temperature is measuring of an object, and T minutes after it is removed from a heat source, the heat is raising the temperature, and suddenly it is removed. Find the temperature of the object at the instant it is removed from the heat source. So the heat source has been, if the object has been removed from the heat source, so the temperature will die out or will dawn after some time. So find the temperature of the object at the instant it is removed from the heat source. So it is removed at the T is equal to 0. So at T is equal to 0, this will be 1. So 55 plus 15, at that instant the temperature would be 70. And find the temperature of the object when T is equal to 8. So in place of T we will place this 8 and we will solve this value. Find the value of T when T is equal to 25. So in place of T we will write in place of T, capital T, we will write 25 and we'll find the value of T. So let's solve this question 9. So at T is equal to 0, so this is small t times 0, this is 70 Celsius, and at T is equal to 8, in place of this T 8, so it will be very less value, so this is 8, so this becomes much smaller, so finally the temperature would be much lower. And at T is equal to capital T 25, at what time it would be? So it will take more time, because after 8 minutes or 8 time value has been reduced, so this value would be reduced taking more time. So this is by placing t is equal to 25 here and by rearranging to find this value t. So this is e power minus point t is equal to t minus 15 divided by 55, and now this in place of t we will write 25 and we will get this value, and then take log n both side, and then solution gives 17.05 minutes. So this would take more than 17 minutes, because it takes 8 minutes to reach this value. So it would take 17 minutes to reach 25 Celsius because of this exponential characteristics. So this is question number 9, and after that I will explain question 11. Do not use calculator in this question. Find the value of minus log p square. Find log 1 over 10 power n, and show that log 20 minus log 4 divided by log 510 is equal to log y square, where y is the constant to be found. And in the last question we have to find log r 2x plus log r 3x plus is equal to log r 600. So we have to solve this problems, 4 problems that was the part of paper 1, question number 3 in 2016. So let's solve question number 11. So this is LP p square is equal to, then this 2 will appear here, so log pp, that is 1, because same base with the same unit. It's because log 10 is always gives 1, so log pp gives 1, log 2 gives 1, or anything if same then it gives 1. So this is minus 2. So for this log 1 over 10 power n, so this is log 1 and minus log 10 power n. So this log 1 is basically 0. So this n will appear here, and log 10. So this is 1. So n minus n is the answer. And for part 3, log 20 minus log 4 divided by log 510 is equal to log y 2. So taking left hand side, log 20 minus log 4. So this is can be write as log 20 upon 4. So this is 20 upon 4 is log 5, and this is log 510. So log 510 is this. So in place of this, it can be using chain rule. So this log 10 can be write down log 10 and log 5 log 10 5. So we already have learned this logarithmic laws. So by using that property, it can be write down as this. This is log 10 log 10 log 10 5. This denominator can be written down as this. So by this we have this log 5 in the denominator. This log 5 will appear in the numerator, so it becomes power square, and this is log 10. This log 10 is basically 1, so log 5 square is log 5 2. So that is basically our y is equal to 5. Then it proves that pi value will be 5. So this is y. This is now let's solve this. Log r 2x plus log r 3x is equal to log r 600. So this is addition. So log r 2x and 3x will multiply. So this is log r 6x square, log r 600. So this on this side we have log r. So this is 6x square is equal to 600. So 6x square is equal to 600 means x square is equal to 100, so x is equal to plus minus 10. Since logarithmic value, so this negative is not possible, so x is equal to 10 is the only solution. So let's solve question number 12. Sketch the graph of y is equal to e power x minus 5, showing the exact coordinates of any point where the graph meets the coordinate axis. Find the range of value of k for which the equation e power x minus 5 is equal to k has no solution. So we have to this if we take this y is equal to k, and we have to find the range of k for which the equation does not give any solution. So this is in the second part we have to give the answer in the form of single log, and in the third part we have to find the value of this x. So let's go to question number 12. So this is y e power x minus 5. So let's x is equal to 0. So if we take x is equal to 0, then it becomes 1. So value is minus 4. At x is equal to 0, on y-axis x is equal to 0, y is minus 4. So this is minus 4. When y is equal to 0, so if y is equal to 0, then e power x is equal to 5. So e power x minus 5, so ex is equal to 5, so x is equal to ln 5. So this is ln 5. Ln value can be calculated as between 1 and 2. So this is this second point is obtained. So this is x-intercept, this is y-intercept, and if we increase the value of x tends to minus infinity, if x tends to minus infinity, then this becomes 0 and y reaches to minus 5. So this y reaches to minus 5. So this is minus 5. So y is equal to minus 5 is the asymptotes. So this is the asymptotes. And for x tends to plus infinity, then y tends to infinity. That is going to the upward. So this is going to the infinity. With the increasing value of x, the y is increasing to the infinity side. So this is the plot which is required. In the part 2, we have to range the value of x for there is no solution. So for x is less than minus 5. So for k value, if this is minus 5, less than minus 5, then this becomes log becomes not possible. If we take this e power x is equal to minus 5, then e power x is equal to 0, that is minus infinity, where the solution is not possible. So this it should be for minus 5, for minus 5. So minus 5, so if less than that, then this becomes minus negative. That is not possible. The exponential is minus is not possible. The exponential value is only possible to the 0. Its minimum value would be 0. So this is not possible. So in a B part, simplify. We have to simplify or write it into a single logarithmic function. So log a under root 2, log a 8, log a half. So this is under root a, this is 8, and this is half, because same power, same base, and no coefficient outside. So this is simple. So this is 4 divided by 4 under root 2. So this is 2 square, and this is 2 half. So this is 2.5. So this is 2.5 will appear first. So 2.5 is basically 5 upon 2 and log a2. So this is 2.5 and log a2. So this is p. This is 5 by 2, or 5 upon 2 is basically the p. So this has proved. And in the C part, we have to solve the value of x. So log 3x is equal to log 9 4x. So this log 9x, so we have to write it in log 3 form. So this log 3 can be written down like this. So this log 9 4x can be written down as log 3 4x log 3 9 is equal to 1. So now we can make adjustments. So this is log 3 4 power 3. So this 2 will appear here, and this log 3 is 1. So this becomes 1 and 2 will be here. So this is simple. Now taking LCM, so this 2 multiply, and this is log 3 4x, and this is 2. So this 2 will be shifted here. So this 2 will appear at the power. So now this can be written down as log 3, and x squared divided by 4x is equal to 2. So this is x log 3, x upon 4 is equal to 2. Now this is if we take 3 here and 3 power 2, so this becomes reciprocal, and x upon 4 is equal to 3 power 2. So this is 3 power 2 means 9 for the 36. So this is 36. So x is equal to 36. So let's solve question number 13. Let's solve the question number 13. That is so here we have a is equal to 9 q minus 1 into 2p plus 1 is equal to 4 power 7, and second equation is 9p minus 4 into 3q is equal to 81. So we take this 2 power 3, and this is 2, this is 2 power 2. So this from the first equation we have right in the same power base 2, and this is 2 3. So this multiply with this one, and this is 2p plus 1, and we can write it like this. Similarly for this 2 powers 14, and this same base, so this power will be same. Similarly from the second equation there is 3 power 2, and this is 3 power 4. So from this we have this equation. So this is 3 2p minus 8 plus q is equal to 3 power 4. So this 2p minus 8 plus q is equal to 4. So this is 2p plus q is equal to 12. So this is first equation, this is second equation. We can solve it simultaneously to obtain the value of q and p. So by solving it simultaneously we have obtained value of q and p, and that is our required solution. In a part B we have log 3x minus 2 plus log x plus 1 is equal to 2 log 2. So from this we can write as single log 3x minus 2 x plus 1, and this can be shifted on this side. So this 2 is also here. So this 2 is here. So this is write down as 2. This is log, so 10 power log 10 power 2. So this is 2 times this factors, and we have this square. Now simplify this, and eventually we have obtained this. Now it can be factorized. So this is 13 into 12. So this is factorized, and we have obtained x minus 4 and 3x plus 13. So x is equal to 4, or x is equal to minus 13 upon 3. X minus 13 is not possible for this logarithmic function. So we have only one solution, that is x equal to 4. So that's all from this chapter 6.